Okay, here we go. We're going to do some word problems, some predicting, some crisscrossing, some balancing. We're going to do it all. All right. First of all, you got to learn to read the questions. That's important. So we'll go through this here. Aluminum metal added to hydrogen chloride gas. So I have aluminum metal, and added is the universal. I have a plus sign to hydrogen chloride gas, HCl. Yields, and yields is the universal symbol, the universal word for an arrow. Aluminum chloride and hydrogen gas. And let us not forget, which several of us did, that hydrogen, along with nitrogen, N2, O2, F2, Cl2, Br2, I2, H2, when it's by itself, and it says hydrogen gas all by itself, there must be a 2 here. It is a diatomic. It doesn't exist as just a single atom of itself running around. It exists as 2 atoms of itself, much like oxygen, O2. Okay, next, charges. We're going to assign some charges. Hydrogen, +1. We're going to use these oxidation numbers, +1. Chlorine, -1. Aluminum, +3. So I have that chlorine, I know. And then single atoms, it doesn't matter what they're charged. You don't have to tell me. I don't care. You shouldn't care because we don't do anything with them. So nothing drops down, nothing crisscrosses. It's all by itself. So all you need to know about single atoms is if it's a single elements, is if it's a diatomic, it has to be a 2 of those things. Okay. So then we're going to crisscross. So this 3 is going to drop down here. And next we have to balance. Well, this is fairly simple one to balance, right? I have 3 chlorines. I'm going to do this over here. Okay, don't know what that was about. Ooh. So I have 3 chlorines, my 2 hydrogens. Ooh, that's only going to give me 3. Let's do this. Let's do 6 here. Let's do 6 here. And then a 2 here. And then a 3 here. And then a 2 here. So now I have 2 aluminums, 2 aluminums. 6 hydrogens, 6 hydrogens. 6 chlorines, 6 chlorines. Done. I'm going to do these without doing atom counts, at least these early ones. I might do some of these. I might do some atom counts just so we can keep it straight. Phosphoric acid, H3PO4, is mixed with plus sign magnesium hydroxide, Mg. Hydroxide is OH. You must know the difference between a hydride and a hydroxide. A hydride is an H. A hydroxide is an OH. Oxide. It's got an oxide in the name, right? Okay, to produce magnesium phosphate. By the way, that's what that is, a phosphate group. And water plus H2O. Okay, and now we have to crisscross charges. The phosphoric acid is already done. This is +2, -1, so I have 2 down here. +2, -3, so I have a 3 here. Let's make a little more room for that. I don't like that. I don't like squeezing stuff in. Gee, I have a 3 here, and I'm going to have to fit in my coefficients anyway. And a 2 here. And water is already balanced. Oxygen is -2, hydrogen is +1, so as you can see, it's already done. Okay, so what do we got? Let's do a count. We got hydrogens and PO4 groups and magnesiums and oxygens. And then we're going to put our line, and we're going to do hydrogens and PO4 groups and magnesiums and oxygens. And I have 3, 4, 5 hydrogens, 1 PO4 group, 1 magnesium, and 2 oxygens. And over here I have 2 hydrogens, 2 PO4 groups, 3 magnesiums, and 1 oxygen. Okay, so what are we going to fix first? What are we going to do here? Do we want to fix magnesiums first? Let's give it a try. Let's throw a 3 out here, and that gives me 3 magnesiums, and that gives me 6 oxygens, and that gives me 6 hydrogens, plus these 3 is 9 hydrogens. Okay, that all seems perfectly okay so far. Now we're going to fix PO4, so I'm going to put a 2 out here, and that's going to give me 2 PO4s. It's going to give me 6 hydrogens plus 6 is 12 hydrogens. Okay, so it seems like we need to fix some stuff on this side, and it seems like if I throw a 6 here, then I'm going to get 12 of these and 6 of these, and I'm going to be balanced. So 2, 3, 1, 6. Okay. That balances up right. And again, it's just playing back and forth. It's just fixing one thing at a time and seeing what it does to everything else. And eventually you'll go, oh, I'm done. I have completely fixed this. So nitrogen and water are produced. So the arrow is here. Nitrogen is here with an N2 plus H2O by the decomposition of ammonium nitrite. So ammonium is NH4 and a nitrite is NO2 and a nitrite is -1 and +1, so it seems like I don't have to crisscross anything like that. Water is already crisscrossed. Okay, so away we go. Now I don't have any NH4 groups or NO2 groups on this side. What I have is nitrogens and hydrogens and oxygens and nitrogens, hydrogens, and oxygens. And I have 2 nitrogens, 4 hydrogens, and 2 oxygens. And I have 2 nitrogens, 2 hydrogens, and 1 oxygen. This is going to be very simple. 2, 4, 2, done. 2, 4, 2, 2, 4, 2. The majority of mistakes balancing that I can see that y'all are making is that you're not keeping accurate atom counts and you're not keeping them clear. You're trying to squeeze them into holes and going carbon and oxygen and okay, if I have 5 of these and then no, wait a minute, I have 6 of these and you're trying to squeeze all this work into a little space and there's no way of really knowing what you have. Here I know I have 2 nitrogens, 4 hydrogens, 2 oxygens. It's very clear. And even if I didn't need to do an atom count, it's very clear what I have. All right, so let's go. So we have iron 3 bromide. So what that means is that this iron is +3. And that this bromine is -1. Bromine -1, hopefully by now everybody knows that, is reacted with ammonium sulfide. So I have an NH4 and a sulfide. I'm going to go ahead and put that in parentheses. And so they haven't told me what my products are, and that threw y'all off, even though you had done the worksheets for 2 days on this. You don't need it. Cation, anion, cation, anion. I think they switch partners, so FeS. Oh, by the way, I didn't crisscross, so -2 and NH4 is +1, so I need 2 NH4 groups. So I'm going to squeeze a little 2 in right there. I don't want to do that. That'll mess y'all up. Let's put the 2 big and bold. That way we know. Okay. So I've crisscrossed. I think I've crisscrossed. Yeah, I've crisscrossed And I got my first product, and I need my second product, which is NH4 and bromine. And so here I have a -2, here I have a +3, so I have to do this. All right. Okay, so it's looking fairly apparent to me. Oh, wow. That's interesting. Well, okay. Okay. So let's do atom counts. Iron, bromine, NH4, and sulfides. And iron, and bromine, and NH4, and sulfides. Okay. So I immediately see that I have 2 NH4s, so I'm going to need to do something about that. But I have 3 bromines here. It's interesting. 3 bromines, NH4, 2, sulfur I have 1, iron I have 2, sulfur I have 3, bromines I have 1, and NH4 I have 1. Okay, what are we going to fix first? Good question. Let's fix irons first. 2, and it doesn't really matter. You pick whatever you want, and now I have 6 bromines. And let's fix sulfurs next. So I'm going to put a 3 out here, and that gives me 6 of these and 3 of these. And it seems like I now need to fix bromines and NH4s, and what I need is a 6 right here, and that gives me 6 of each. And I am done. That is balanced. Balancing shouldn't be tripping y'all up anymore. All right, number 6. Aluminum hydroxide is reacted with pure magnesium. And it goes to cation, anion, cation. Now, there is going to be a case where you're going to have, let's say, an aluminum and an oxygen, and you're going to have another anion. And so these anions are going to switch places. So once you go over, you're going to have aluminum chloride plus oxygen. That's going to happen. It's not always cation, cation. I'm hoping you know this by now, but hopefully I can give you some practice on, anions that will switch places too. But anyway, right here it's cations, so magnesium is going to end up with the hydroxide plus aluminum all by himself. And +2 minus 1, so that's 2. +3 minus 1, so that's 3. Okay. So what I have here is I have a 2 and a 3, and I'm never going to get them to equal each other, but I can multiply this by 3, and that gives me 3 magnesiums and 2 hydroxides. And I can do this by 2, and that gives me 2 aluminums and 6 hydroxides. And then I can put a 3 in front of this and a 2 in front of this, and I am balanced. 2 aluminums, 2 aluminums. 6 hydroxides. 3 times 2 is 6 hydroxides. 3 magnesiums, 3 magnesiums. Done. Oh, did you need types? I don't know if you wanted them or not, but this is single replacement. This is double replacement. Oh, sorry. Double replacement. This is decomp. This is double replacement. This is single replacement. The single replacements and the double replacements are generally the ones you're going to see. All right, last one. Calcium hydroxide is reacted with zinc. Okay, so it goes to zinc hydroxide plus calcium. And calcium is +2, and this is -1, so that's 2 hydroxides. And zinc is +2, and this is -1, so this is 2 hydroxides. So it looks like I am balanced. 2 hydroxides, 2 hydroxides, 1 calcium, 1 zinc, 1 calcium, 1 zinc. Done. And that's it. This is a single replacement if you needed to know. If there's anything you need to know, my remind is available on the e-class. Just send me a remind. I'll try and send you out an answer as best I can, or I'll take a picture and send it to you. Whatever I can do to help you. That's what I want to do. I want to see everybody in this class succeed. So just ask and it shall be made apparent. Anyway, I hope this helped out, and I'll see you in class tomorrow.